Welcome to the video on dimensional analysis. We'll start off by talking about temperature. But first, here's a cute comic that talks about the difference between metric units and English units when you're trying to have a discussion with somebody about football. So that's cute, and you can take a look at that if you're interested. On this slide, it just shows 4 examples where errors in units created quite big problems. In 1983, Air Canada had to make an emergency landing because the fuel tanks were calculated in pounds instead of kilograms. In 1999, a Mars spacecraft was lost attempting to orbit Mars because one group did their calculations in English units and the other had used metric units. In 1993, a nurse accidentally gave 23 units of morphine to a patient rather than 2 to 3 units. And so we have to make sure we know where the decimal place is. And today, Johnson & Johnson, the company that makes Tylenol, is having to redo the dosage when they compare infant Tylenol to children's Tylenol. Those are 2 different concentrations, and so the dosages are very different. The company is figuring out how to make sure that the patient's parents don't actually interchange those 2 medicines because they're very different. So numbers matter very much, and units matter very much. And so this chapter is all about numbers and units. One of the things that we're going to absolutely have to convert because the units are different is temperature. You've heard of Fahrenheit. That's the system that we use typically in the United States. So Fahrenheit is where water boils at 212 degrees and water freezes at 32 degrees. So that's the Fahrenheit. Then we have the Celsius, which is a metric unit, and that goes from 0 to 100 in terms of boiling and melting. So water freezes at 0 and it boils at 100. And so this scale makes a little bit more sense in terms of water. And this scale is the one typically used in science, is Celsius. There's a third way to measure temperature, and that's called Kelvin. And that one is used because scientists need to get very, very cold. The temperature at which all things cease to move is 0 degrees Kelvin, which happens to be negative 273 degrees Celsius. And so those scales are the same, but they're just put off by 273 degrees. Whereas Fahrenheit, that scale is very different. We have 100 degrees separating boil and freezing of water for Celsius. 212 minus 32 is 180 degrees. So you're going to see 1 degree Fahrenheit is not the same as 1 degree Celsius. However, 1 degree Celsius and 1 degree Kelvin, those are equivalent. If we look at how to convert these temperatures back and forth, we're going to use an equation, and you will be given these equations on the exam. So if you're given degrees Fahrenheit, you can plug it into this equation right here to calculate degrees Celsius. If you're given degrees Celsius, you can use this equation to calculate degrees Kelvin. And if you are given degrees Celsius, you can use this equation here to calculate degrees Fahrenheit. And so let's go ahead and get some practice in on these conversions. So a normal human body temperature is 37 degrees Celsius. What is this temperature in Fahrenheit? So the equation we're going to use here is the temperature Fahrenheit equals 1.8 times the temperature Celsius plus 32. The Fahrenheit temperature equals 1.8 times the temperature Celsius plus 32 degrees. And so in order to calculate the degrees Fahrenheit, we're going to say 1.8 times our degrees Celsius, which is 37, plus 32. So if I do the math out, 1.8 times 37 is 66.6. Okay, now I'm not going to round yet, but if I look at my significant figures, 1.8 is 2 and 37 is 2. And this is multiplication. So we're going to want 2 sig figs in our answer. So this place right here is where we're going to ultimately round to, but we got to leave the 0.6 there so we can do the calculation correctly. So then if we have 66.6 and we add 32 degrees to that, we end up with 98.6 degrees Fahrenheit. And although our significant figures say that we should round that to 99, we all know 98.6 is the normal body temperature of a human being. We talked about absolute zero. That's theoretically where all motion stops. That occurs at 0 Kelvin. So what is the temperature in Celsius and in Fahrenheit? If we look at our original equation that says our temperature Kelvin equals our temperature Celsius plus 273. So if we have 0 here, we want to calculate what Celsius temperature would this be. So the way that we do that is we subtract 273 from both sides, and we end up with negative 273 equals temperature Celsius. And so that would be negative 273 degrees. So if we're going to use the same equation above, temperature Fahrenheit equals 1.8 times the temperature Celsius plus 32. And we know that our temperature Celsius is negative 273. So our temperature Fahrenheit is 1.8 times negative 273 plus 32. So if I punch into my calculator, 1.8 times a negative 273, this value right here is negative 491.4 degrees. And if I add to that 32 degrees, now you can do this all in one step in your calculator, but for those of you who want to do it stepwise, I'm showing you. If we add 32 to that value, so the answer would be negative 459.4 degrees Fahrenheit. Oops, I forgot to put our units over here, degrees Celsius. So on the third problem, we're given Fahrenheit and we need to go to Celsius and we need to go to Kelvin. The equation that we use to get from Fahrenheit to Celsius is temperature Celsius equals temperature Fahrenheit minus 32. So we're going to do that subtraction first, right? Because that's in the parentheses. And then we're going to divide that answer by 1.8. And then we'll do Kelvin separately. So our temperature Celsius is what we're figuring out, and our temperature Fahrenheit is 77. So if I solve this problem, I have my Celsius temperature equals 77 minus 32 divided by 1.8. And so if on my calculator I type 77 minus 32, enter, I get 45 on the top, and then I divide by 1.8. So I take 45 divided by 1.8, and I get 25 degrees Celsius to make that complete. So 77 degrees Fahrenheit is 25 degrees Celsius. And if you've ever traveled to Canada or to really any place besides the US, you might remember that the temperature was in the 20s if it was a normal summer day, say 77 degrees Fahrenheit. Now, to get 25 degrees Celsius into Kelvin, we're going to use the equation temperature Kelvin equals temperature Celsius plus 273. So temperature Kelvin equals 25 plus 273, and that equals 298 Kelvin. Now, this is the first time we're reporting an answer in Kelvin, and so we don't put degrees. Kelvin is just Kelvin. We write the degrees symbol for both Celsius and Fahrenheit, but we don't need to write it for Kelvin. Okay, so there you have it. This is what we're going to have to know. We're going to have to know how to go from Celsius to Fahrenheit, like this question. We're going to have to know how to go from Kelvin to Celsius, like this one. We're going to have to know how to go from Celsius to Fahrenheit, like this one. And then we're going to have to know how to go from Fahrenheit to Celsius here, and then from Celsius to Kelvin here. So those are the different ways that we'll be able to do these temperature conversions using the equation on the previous page. And again, these equations here will be given on your exam. You might want to just write them someplace where you can have easy access to them for homework problems and for Alex. Good luck with this.